Welcome to The Explainer. Today, we're going to dive deep into one of the most essential pieces of cybersecurity hardware out there, the network firewall. We're going to break down what it is, how it works, and why it's so critical for protecting our digital lives. Okay, so to get our heads around this, let's use an analogy. Think of your computer network, your home Wi-Fi, your office network, as the most exclusive VIP club in town. You can't just let anybody walk in off the street, right? Of course not. You need a bouncer at the door, someone checking IDs, making sure only the right people get in. Well, that's a firewall. It's the bouncer for your digital world. So, to put a more formal definition on it, a firewall is a security device that sits there and just watches all the traffic, everything coming in and everything going out. And for every single piece of data, it looks at a rulebook that you've defined and makes a simple choice. You can pass or nope, you're blocked. It's that digital checkpoint at the border of your network. Now, for any device to truly earn the name firewall, it has to have three core properties. First, it's got to be tough. It has to be able to resist attacks itself. I mean, you can't have a security guard that gets knocked over by the first person who tries to get in, right? Second, it has to be the one and only way in a route. It's the single choke point. And finally, it has to be the enforcer of your access rules. No ifs, ands, or buts. But here's the thing. Firewalls didn't just appear out of thin air looking the way they do today. Oh no, they have evolved a lot. It's been this constant cat and mouse game, a technological arms race between attackers and defenders. As the threats got smarter, the firewalls had to get smarter too. So let's go back to the beginning. Generation 1, the packet filtering firewall. This is our bouncer with a super simple black and white guest list. It only looks at the most basic info, the source and destination IP addresses and the port numbers. Think of it like a mail sorter that only looks at the to and from address on the envelope. It's not looking at what's inside at all. It was fast, it was simple, but, not exactly the most thorough security. And that simplicity was both its biggest strength and its greatest weakness. On the plus side, these things were fast, cheap, and pretty easy to implement. But the huge downside was that they were stateless. That means they had zero memory of past connections. Each packet was a brand new decision. This made them super vulnerable to things like IP spoofing, where an attacker could basically fake their return address and trick the firewall. And man, trying to manage those rule lists, the ACLs, could get crazy complicated. So clearly, that memory problem had to be solved. And that's where Generation 2 comes in, the stateful firewall. This was a huge upgrade. Our bouncer now has a memory. They don't just check the ID of everyone coming to the door, they remember who they already let in, and they keep an eye on the conversations they're having inside. This is all tracked in something called a state table. Just by adding that context, that state, the filtering became so much more powerful. It could now spot and stop things like denial of service attacks because it could see this flood of traffic wasn't part of any real established conversation and just drop it. The big limitation, though, it still couldn't understand the content of the conversation. It knew two people were talking, but it had no idea what they were saying. And that brings us to Generation 3, the application gateway, or what we often call a proxy firewall. This is where the firewall gets really, really smart. It basically acts as a middleman for the entire conversation. It inspects everything all the way up to the application layer, layer 7. So now our bouncer not only recognizes you and remembers you, but they also understand the language you're speaking. They can actually tell if you're trying to hide something malicious in your words. Which leads us right up to the present day with Generation 4, the Next Generation Firewall, or NGFW. You can think of this as less of a single bouncer and more like a fully integrated security team. It takes all the good stuff from the previous generations, the stateful inspection, the application awareness, and then it adds a whole bunch more, like intrusion prevention systems, threat intelligence feeds, the whole shebang, all in one box. Okay, so we've seen how firewalls have evolved and gotten smarter, but listen, even the most advanced firewall on the planet is totally useless if it's not in the right place. It's not just about what you have, it's about where you put it. The blueprint for your defenses is absolutely critical. The most basic setup, the one you'll see everywhere, is the simple private and public architecture. It's exactly what it sounds like. You've got your trusted inside network, and then you have the untrusted outside world, the internet. The firewall just sits right on that border, separating the two. For a lot of situations, it's simple and it works. But what if you have servers that need to be accessible to the public, like a web server or a mail server? You don't want to just punch a hole through your firewall and let everyone into your private network. No way. The solution is called a DMZ, a demilitarized zone. The best analogy is a reception area in an office. Visitors can come into the lobby and access public resources, but they can't get past the front desk into the actual offices without going through more security. That's a DMZ. And for even more complex networks, we go a step further with zone-based policy firewalls. This moves way beyond that simple inside versus outside idea. Instead, we create multiple different security zones, like a zone for our users, a zone for our servers, maybe a separate zone for guests. Then we write super specific rules for how traffic can or can't move between each of those zones. It's incredibly powerful and flexible. But here's a really important takeaway. A firewall, no matter how powerful or perfectly placed, should never be your only defense. It's just one piece of the puzzle. It's a critical part of a much bigger strategy that we call defense in depth or layered defense. The whole idea here is to build a fortress with multiple walls. You start by securing the individual devices, the endpoints. Then you secure the communications flying between them. Then you secure the perimeter between zones. That's where our firewalls live. And finally, you protect the core of the network itself. If one layer fails, you've still got others to fall back on. So how do you actually run one of these things effectively? Well, there are some golden rules. The absolute most important one is to start with a deny all policy. That means, by default, nothing gets through. You then have to explicitly permit only the specific traffic you need. It is so much safer than leaving the door open and trying to block the bad guys. Also, and this is a big one, you have to control physical access to the firewall. If someone can just walk up and unplug it, all your rules are worthless. And of course, you have to constantly watch the logs and have a rock-solid process for making any changes. And that kind of brings us to our final thought. We've seen this incredible evolution, from simple packet filters to these intelligent all-in-one security platforms. But the world keeps getting more complex. Our networks are moving to the cloud, to the edge. Threats are now being powered by AI. So the big question is, what does Generation 5 look like? What comes after the next generation firewall? That's the puzzle that cybersecurity experts are trying to solve right now.